Okay, on this part, they want us to, let's see, use the Maclaurin series expansion for cosine x. Which looks like this. Okay, use that to find the first two non-zero terms of the Maclaurin series expansion of cosine of e to the x. Okay, so cosine of e to the x. We're going to first replace all of these with e to the x, and if we do e to the x squared, that's going to multiply to 2x. And then this would be e to the 4x. This would be e to the 6x. Okay. Now, from here, we found this, and then we're going to just bump it to our nx formula. So on the previous video, we found these, and I'm just going to plug them in. So we still have this 1, and then I'm going to bring this out in front, so it's 1 over 2 factorial, and then the expansion for e to the 2x that we found on the previous video is this. And then I'm going to do a similar thing, 1 over 4 factorial, and then the expansion for e to the 4x looks like this. And then continuing on with that, now if we look at the just how this expansion is going, the last is going to be -1 to the k, 2k factorial. So where I come up with this, so this is like our 0, this is our 1, this is our 2, and so we see that the signs are changing, so that's what the -1 to the k does. So if we plug in a 0, it becomes positive. If we plug in a 1, it's negative. A 2, it's positive, so on. Now if we look at the factorial on the bottom, this 1, we have to times it by 2 to get this factorial. This 2, we times it by 2 to get this 4 factorial. And so this is representing the pieces that are just like out in front. So like those two pieces are represented by this. Now after that, we get a 1 in both of them. And then we're going to take this number again and times it by 2. So it's going to be 2 times k and then an x. Right here, we're going to take this number, times it by 2, and then square it. So it's going to be 2k squared, and then x squared, and then it's just a 2 factorial on the bottom, and then this will continue. Okay, now what we're going to do is write this in summation form. So we get 1, and this part is going to be actually what I'm doing, taking this and I'm distributing it, and we just need the first two non-zero, so we need the 1 and the 2. So this times 1 is going to look like this. And then this times this is going to be and then my x is out there. Plus dot dot dot. Okay. Now, if we have 2k on top and 2k, so if we had like, let's say it was just like 6 over 6 factorial, for example, we could cancel the 6's and the bottom would just be a 5 factorial, so it'd be 1 over 5 factorial. So when we're thinking of k, it's just 1 less factorial. So these can cancel, and we get 2k minus 1 factorial on the bottom. And so what I'm going to do is I'm going to write my cosine of e to the x is approximately 1 plus this, k equals 1. Okay. So I wrote that up there because I need to get rid of this to do the next part. So that's our answer for B. Get rid of all that. Okay. Now in part C it says, hence show that x near 0, e or cosine of e to the x equals cosine of 1 minus sine of 1x. So, or what am I trying to say? X near 0. Okay. So we're trying to prove this true when x is close to 0. Okay, so if we get like x squared and x cubed, etc., as x tends to 0, these also go to 0. Okay, so we're going to look at cosine of 1. Oops. So I guess actually let's write down cosine of x, which is 1 minus x squared, 2 factorial, x to the 4th, 4 factorial, x to the 6th, 6 factorial. Okay. And so if we look at cosine of 0, or I mean cosine of 1, because in our formula it's cosine of 1, we're going to get 1 minus 1 over, all the tops of these are going to be 1s. Okay. And then if we write this in summation form, we have a 1, and then we want the signs to flip. And so the signs, when they flip, we have to get negative 1 to the k. And then once again, this is 0, 1, 2, 3. And notice how we're just multiplying these numbers by 2. So that's going to be 2k factorial. So this is our summation of cosine of 1. Okay, we'll do the same thing with sine. So we'll write down sine of x, which is x minus x cubed okay, and then if we look at sine of 1, we're going to get 1 minus 1 over 3 factorial plus 1 over 5 factorial minus 1 over 7 factorial, etc. Now, this one, we could think of it as 1 over 1 factorial, and that's going to make our summation a little bit nicer. And so we're going to do this thing where we flip the signs. And then on the bottom, we just want so once again, 0, 1, 2, 3. So we want to plug something in that will give us an odd number every time. And that's going to be 2k minus 1. Because if we plug in a 0, if we plug in a 1, we're going to get 2 minus 1, which is 1 factorial, and that's right. Then we plug in a 2, we get 4 minus 1, which is 3 factorial, so that's the next one, and so on. That's going to work. Now we check the signs here. If we plug in a 1, we're going to get, this is a little confusing, because this would be k equals 1, k equals 2, k equals 3, k equals 4, etc. So it's kind of shifted because we didn't start with this 1 out in front like we did up here. The issue is if we plug in a 1 here, we're going to get a negative, so that's wrong. And then if we plug in a 2, we're going to get a positive, which is wrong. And so to fix this, we're just going to put a negative sign out in front right there. Okay. Now, if we look at this, so we're going to look here. So if we do cosine of 1, we get this thing, which is exactly this thing. And then we're going to minus a sine 1 of x. And because minus minus goes to positive, this minus and this minus make this positive. And then we see that this is the same thing as this. So that all worked out. Now, on part D, it says find by direct calculation the Maclaurin polynomial of degree 2 of cosine of e to the x. Okay, so to do that, we have to get rid of all that. Cosine of e to the x. Actually, let's write it like this. F of x equals cosine of e to the x. And if we take the derivative of that, the derivative of cosine is negative sine. Rewrite the inside, and then multiply by the derivative of the inside. Now, when we're trying to find the second derivative, we're going to call this a. We're going to call this b. So a prime is going to be negative cosine e to the x times e to the x. And the derivative of b is going to be e to the x. And so we write the first one. Derivative of the second one. Write the second one times the derivative of that one. And then we can simplify this just a little bit. So we're going to say negative e to the x sine e to the x, and then minus, we have 2 e to the x's, so when we combine those we get e to the 2x with multiplication. And then cosine e to the x. So here's our second derivative. Now what we're going to do is plug in zeros for all the x's. And so when we do that, let's get rid of that. Plug in a 0 here, we're going to get cosine of e to the 0, which is cosine of 1. So f of 0 equals that. If we plug in zeros here, we get negative sine of e to the 0 times e to the 0. And so the first derivative at 0 is going to be negative sine of 1, because this goes to 1, this goes to 1. Okay. And then the second derivative, we're going to get negative e to the 0 sine e to the 0 minus e 2 times 0 cosine e to the 0. So that just goes to negative 1. This is just sine of 1. This just goes to negative 1 and cosine of 1. So when we write this as a Maclaurin polynomial of degree 2, it's going to look like this. So m2 of x equals cosine of 1 minus sine of 1x minus sine of 1 plus cosine of 1 x squared over 2 factorial. Alright. If you need additional help, please come to Math Lab. Until then, calculator.